Hello everybody, thank you for tuning in to the Wheel Fix It team. Today is another really off video from our normal mechanical stuff. Not a technician like I said before, but I do my best to keep some of my locals running. And what we have here is an old school Dentron Clipperton L, which has it's an RF amplifier for ham radio use. But it's got 4 of these 572B vacuum tubes in it. This one here is a pretty hefty model. Looks like it's an original Peter Dahl transformer that was maybe it came original to this vehicle. And what this thing's doing is low RF output on his setup. The guy told me it was only doing about 400 pp watts, and it's SSB would be considered high. That's where your plate voltage should be. At 2750, that means that needle should be, a little ways past that 2500, and it's only showing me approximately close to 2000 plate volts, which could be part. That may be why you're not getting enough output. The tubes might be fine. You have to have a certain amount of plate voltage for this thing to work right. When low, it goes way back. It goes almost to 1200, which it should be around 1800 or so. And a visual inspection shows where we've got some diodes. I've already made sure this thing is not plugged in. We've got our safety jumped out so we can diagnose some stuff. But we're looking at some diodes that are on the down here, and there's also some capacitors, capacitor bank. And I did some simple testing first. First, I made sure on my power it was still showing the same plate voltage. Make sure it wasn't something on his line voltage in, and also I checked to make sure that the plug-in, because this is wired for 220, that everything was up and up there, that we weren't just running off one side of the plug-in, which that checked out well good. The next thing is we're going to check to see if we've got actual, only if this meter's right. I want to be sure I'm not just chasing the wrong dragon here. Fan's kind of noisy. And we're going to see what happens there. But so I've got my Simpson meter hooked up. It's an old Simpson 2670. I keep forgetting which one model it is. I got a 260 in the other drawer, but this 270 has the ability to look at voltages up to 5,000 volts, and so we should be within range of the meter's capability at 2750, and we have it set up for that. So now that we're clipped to our anode, which should see 2750 grounded to the chassis, we've got our leads to our meter. We're going to set this thing up, plug it in, turn it on, and see what the meter shows. Okay, so we're going to power this thing up, and we're going to see what happens. Now, you got to remember this is very high voltage. Even at its lower scale, it's deadly, so we need to be very, very careful. We're plugged in. We've got our meter hooked up, and we're going to see what happens here. So here, let's flip this thing on. We're on the low scale. We're on CWX, and so we're just barely creeping up. Let's see what the meter shows there. Yeah, that's way down. That's way down. That should be around. That should be almost close to that second line for 1800 volts. Let's see now. We're in high, and watch it just barely creep up, which means we should be at least halfway or a little better to the next line over where it says 6 or 150, and we're just barely creeping up the 2000 mark, which that's what we're showing on this meter right here, which means the meter on the front is reading properly. And so we definitely have problems. That's a start. We need to get our plate voltage up before we go any further. So I'm going to turn this back down into low. And we're gonna power it down and let it bleed down. It'll take a little while for it to do so, and there's some bleeder resistors that are actually, you'll see some of those in line there. The little circular things are disc capacitors that are in line with the diodes, and they're there to kind of just smooth things out, I guess you would say. But it's bleeding down slowly, and we're going to use our J-pole to make sure that it's properly bled down. It's going to be unplugged from the outlet that it's plugged into, and then we're going to start checking diodes. This thing's got a just doubler system set up, and so if we lose half of that, that could be where our or where we're losing our plate voltage. So that's what we're going to do next. So we've got to take the bottom off, and yes, you know, technically you'd want to take each diode out and check it out of the circuit, but I can kind of tell what's going on just going across them from the bottom of the board. And so that's our next step to see what happens there, because like I said, we've got to have more plate voltage. So here we go. So it's going to be hard to see in the camera, but there's something weird going on with that one solder joint, which that's not, I don't think that's, that looks broken right there. The solder actually looks pushed down away from the board, but it looks like that's broken loose, and we will repair that. I don't know that that's the exact problem though. So we're going to go back. Let me zoom back out here, and I'm just going to run down the line of diodes, and you're going to hear the meter beep, and I'm going to look at the reading on it. Let's see. Well, I'll bring the meter down, that way I don't have to, we can both kind of see it together. Let's see, we're going to diagnose this thing to see what we can see there. Can you see that in my meter? Okay. All right, that looks really good there. Okay. And so get in there. 482, that's normal. Next set down. Yeah, that's pretty good. Next one down. It looks good. 545. So, I mean, but I don't have these out of line. But we're just going to see what we see there. That's the same one. I'm just rechecking. Okay, so that looks pretty good. Let me get a line on where the next diodes are. Okay, down at the bottom. The bottom. Okay, so. That's not bad. It looks pretty good. That looks pretty good. That looks, see, they're pretty consistent across the board. Okay, that looks really good. And the next one would be, this would be the one going to our anode. You notice this red wire travels along. It goes to the, that's coming from the transformer center tap. I mean, not center tap, but one of the secondaries. And then this one's going to our plate choke. That's where our high voltage is going to come out at. So that looks pretty good. So that's a good sign, I guess. So the next thing will be to repair this solder joint that I see right here, and it looks pushed away from the board. You know, and it's. Let me see if I can zoom in on that. I might have to get in there. Bear with me. Let me turn a little bit and get centered up. I'm sorry for moving the camera, but it just it definitely looks to be broken loose right there. It's not it should show me something on that meter right there, and that's a resistor going to, I think, a bleeder that comes from over here. So we're going to fix that, because that is a problem. I don't know how much of a problem that is yet, but I know that it's not right, because I can get a reading there and I can't get nothing or anything there. And then we'll power back up and see what happens, if anything good happens after that. So let's try that. I've got to heat up my soldering iron. Like I said, I don't know that this repair is going to be the fix for what I've got going on, but we do want to fix what we see wrong. And I've made a little, since that trace is actually part of the board and it's broken loose, I just want to making this to kind of make up for that trace not being there. We'll cut the excess off, of course. because like I said, the trace itself is broken loose, and we don't want that to be an issue. I mean, I can throw solder over the top of it and it might be fine, but that thing's kind of down and away from the board, so to keep from it being a broken part later on, putting that on should prevent that. So we'll cut this little excess off of there and get rid of that. Now, next thing we do is to tip this thing back up, repower it, just to see if it makes a difference. We're going to give it a go. All right, so we're confident that the meter's accurate here, so we're not going to hook back up to our Simpsons. We're just going to use this meter on the front to see what happens. No, I don't think that's going to be our fix. No, I was a little, I didn't think it would do it either, but cause I think that all that was just a bleeder. It's up a little bit. It helped some, because if I recall, I remember it not being that high, but it should still be over 2,500 easily. So that's not the exact problem. So we're going to need to go a little bit deeper into this and look and see what kind of power is actually coming out of the transformer. I hate to know that. Now, what I may do is disconnect the anodes off the vacuum tubes, because we could have a tube that's pulling down that's actually kind of shorting a little bit, and see if that voltage comes up. I've seen that happen before. So I have all of the anode or plate voltage or high voltage connections off of the tubes there, and I've got them placed to where we should have an arced chassis. So like I say, you always want to be sure, double check with a J-pole or some sort of device to jump that over to make sure it doesn't have anything, even though your meter shows 0 on your, like it's bled down. You never trust that meter. Always have respect for this extremely high, and anything voltage-wise, even low voltage. Just treat it like it's, going to get you, because you don't want to think that it's not, because as soon as it does, it is too late. So now we've got those disconnected. Let's just see what kind of numbers we get out of it now. Yeah, it's still not coming up. Still not coming up. It's definitely a little higher than it was. We're getting a little bit more every time, but that's not the problem. That's not the problem. It should be, up above 2,500. A capacitor could do the same thing. Could be pulling it down. It's just strange that this thing supposedly was working before it was turned off. It's low. We're at 15 instead of 12, but I still don't think that's the problem. So we'll move on a little bit more. Let's see what's up. So I've been kind of moving along. The last bit of this, I was thinking, we're going to try just kind of rebuilding some of this high voltage stuff. I'm using the old board. Harback makes a kit that you can replace, put a whole new board and stuff in it. And at this point, I want to be sure I don't spend any money on something that's not worth putting it in. And I'm doing a pretty clean job taking out some of these old big dookie caps. Now, something I noticed on a few of these caps that I took out real quickly is you can see that right there. That right there is not a good sign. That when I'm pointing at is on this positive lead, it's got some stuff gooking out around it. A couple of them were like that. Let me see. There's another one. Where's it at? Like, okay, yeah, right here. There's another one right there. That's not good. And I don't know if this is going to fix it or not. I don't want to just say, well, your transformer's bad. And I know what you're saying. Well, test it at the output of the, the leads on the transformer itself. And it's, I didn't want to disconnect anything but I tested it. It looks like it's down a little bit too. I don't want to say it's a transformer unless I at least try. And the guy that owns this thing would want me to try this anyways. He's disabled, and he's a good friend of mine, and just trying to keep him going. He's a good dude, and I don't know how much longer he's going to be with us. So if I can just try to get this thing to work for a little while longer. So now I've got some more diodes laid out that's going to go in here. But basically I'm using not as big, they don't look as big. It's a lot smaller capacitor. However, these were made back in the late 60s, early 70s when this box was made by Mallory, 125 microfarad, 450 volt DC. I'm using 450 volt, 150 microfarad. So I'm actually adding some filtration to this, which won't hurt. Voltage is at the same rating. These are Nichicon. These are the high rate capacitors, 105 Celsius, industrial grade. It's just that they modernize stuff, and they can make these smaller now, and so that's why you see such a. I've used these a lot. This will be fine. This will work just fine in this box. People that are saying, "Wow, those are a lot smaller than what you were taking out." Yeah, well, actually, theoretically there's more there than what I had in this, and it's be better than what it was, which was that stuff you seen leaking out. So I'm down to my last capacitor, and I've been real careful. I use a special device here where I can desolder. It's got a suction gun, and I've got a really decent, neither one of these are very expensive items. Amazon finds. I got that for Christmas from my wife. I bought this, and they're not very expensive. That's got a heat gun and that's I think so handy for doing. You can actually desolder large components with multiple leads with that thing, but I use it for just helping me strip wire a lot. So let's get the camera set up, get this last capacitor out and soldered in, and then I'm gonna go ahead and just do diodes in it. Just be done, even though those kind of checked out good while they're in circuit. The time I take them out and the price I can get those things for, I'm just going to put some new ones in. That way we can say it's all been replaced. The only thing left is the transformer, because we've done everything else under the sun. I've even checked voltage coming in the line cord to make sure that there's no problem with the line cord. I had this thing off camera. I did that where I turned the box on under a load, and I had a meter probe where the tack strip was going to the transformer to make sure that line voltage wasn't pulling back there, and that checked out good. So if this doesn't fix it, transformer's done for. But we'll see what happens there. So here we go. Kind of zoom a little bit so you can see a little more. I've marked some of the places, and I've had to jump over to these can capacitors have a lot more surface area where I could, they would jump over to our bleeder resistors that you see right here, but I had to make those little jumpers to make that work, and so that will be fine. That will be fine. Get this out here. These traces on this board are very delicate. It's not the end of the world if you mess one up, but I'm trying to be really careful to not do that. Alright. Hopefully I don't tip the camera over when I pick this up. There's another one. And that's got some stuff leaking out around that as well. I mean, we can just only hope for the best. Hope for the best outcome at this point, and I don't mind doing this kind of stuff. This is actually a fun little hobby for me, so I enjoy what I'm doing. It's not like I'm hating life over here. And if I get some a neat outcome out of it, then I get to be the hero for the day. And so then that's kind of the way I look at it. So here we go. So by the way, one lead's longer than the other, and it's obvious because I have a negative indicator right here. But on this radial capacitor, those positive leads long. Same LED bulbs are the same way. Little LED lights, their positive lead is going to be a little longer. That kind of helps indicate which way you need to put that thing in a circuit. Axial capacitors, the positive end will be the end that's got like the felt looking stuff, and then your negative end is actually the outside of the can. So anyways, a little something to go by there, help you out a little bit. Oh, okay, so this needs to go in like that, and it's not looking too bad. When I get it all done and flipped over, it won't be the end of the world. But I'm going to move my camera. All right. Push this down a little bit. Yeah. Maybe I'll stay put. Alaka Blammo. So that's looking pretty good right there. Yeah, I can deal with that. Looks good for my house. As long as it's not too close to the bottom to arc. Oh, we got another breaker on the CV. I gotta go answer that. Okay, so we've got our stuff soldered in for the capacitor banks. Let's see what it looks like from the top side now and see how butchered it's going to look. Like I say, as long as it's installed properly, that's really all that matters. But I want it to look somewhat good. Putting up some of this stuff here. This thing still got, looks like a whole set of original, what are these here? No, they're Taylor tubes. They ain't the original tubes, but oh well. They're not original tubes. Oh, heavy dookie butt transformer. Let's see what this looks like from the top. It's a little bit little archaic, but it'll work. It will definitely work. It doesn't look as filled up in the bay as it did with the big dookie caps that it had in it. But it definitely will suffice so far as none of them are shorted at this point. And it's funny too, because I'll show you a quick little segment here in this video. You know, and these things are okay to have. They're good for just checking maybe the possible value of things. But you know, you see these for sale on Amazon and stuff are really cheap. And I'm going to show you something. If you've got a second, I want to hang out before, because by the way, this video's several days in the making, just because I just work on this little stuff in the evenings, and so I probably started this project 3 or 4 days ago, just to let you know that it's not all one shot. But this capacitor, you see, it's got dookie coming out of it. And we'll zero this thing in real quick just to show you how not effective these. As far as to really test a capacitor, you need to devise a method that's a little more finite than this here. The high voltage capacitor testers are bringing it up to its actual voltage. So there we go. 470 microfarad, or 47 microfarad at 470 farad. So we've got a pretty good range there. Let me hook the leads up to this here. They're short for a reason, by the way, in case you're like, just hook you some alligator. No, you got to have these little short leads on it, because the lead itself, it's got capacitance in it. Let's see if it shows anything. I haven't checked this capacitor to see what it's going to show. I don't know. That one there might actually give me a good reading. 16 microfarad. Okay, so that's... These are supposed to be discharged anyways. Let's check another one to see what it shows. Like I say, we'll even run a discharge lead across there just to see, make sure that I don't know, this thing works a little bit. It's not the best. That's cheap. I need a better capacitor tester. Let's see if it. We'll go to a different range. Calculating. Well, if this thing's if this thing's correct, these capacitors are junk. Let me just move this range around here. 0 to 47 nanofarad. Manual 47 nanofarad to 40. Let's see what it shows here. Huh. Nah. It's, like I say, not the best capacitor testers, in my opinion. So, like I say, to really test these right, you need something better than what I got here. I just wanted to show you that these how somewhat effective these things are. We should be, oh shoot, 47 microfarads at 470 farad. That's a big old range. Let's just test a good capacitor and see what it shows. See how well this tool works. Look it up. Let's see. We'll go positive on the big lead, negative on the little lead. Let's just see if it'll show anything. Should show about 150. Yeah, I don't know. I don't know what's up with that. Yeah, it shows 150 there. 47 to 47 microfarad. So that's not bad. That one shows. We'll just recheck on that mode just to double check. So that's a good capacitor. So maybe we've got some bad caps. Maybe this thing is actually working. Checking one that's. Well, that one, it checks out, sort of, kind of. You see that? I don't know about that. I mean, it's within the value, because that's 125 microfarad. That's a 150. But there's dookie coming out of that capacitor, you know? So, yeah. Try a different one. Like I say, they'll check. I've seen this thing check them out and say, well, it's not bad. But when you see chunks coming out like that right there around the edges, right there, that's the leak. That's leakage. And I've seen several of them that look like that. So next we'll tackle the diode section. That way we've eliminated any possibility, and then we'll fire it up without the tubes in, of course, to make sure that there's no pull down. And to see that voltage should jump straight up. It should just be. I could show you on another Clipperton that I have. If I turn this thing on, it just goes boom right over the 20. I mean, where the needle is on the front. If I flip this thing on, it should just jump straight over there. It shouldn't be like creeping. That's not right. All right, so we'll see you through the movie magic in just a second. So we're ready to fire this thing up. I've got all the stuff back. You know, we've got all of our diodes have been replaced. All of our caps have been replaced. The reason why you see some fuses laying here is because this amplifier on the back there, according to the tag, requires a 30 amp fuse. And I've done a bunch of work in here, and I do believe I've got everything sort of in place enough. I moved that with my hand anyways. In place enough that I got all this stuff in here. I don't want to, if something's not right, I'd rather have a lighter fuse in there. So I put a 15 amp fuse in place of the 30, just to be sure that we don't, if something's not right, it wouldn't take as much to blow the fuse and maybe not damage anything. I mean, I trust my work, but I'll be honest with you, I think it's a good idea just to do that. So we're going to jump out the safety switch carefully, because we don't have the top on it, and like I say, high voltage is dangerous. We're going to make sure it's off. We're going to plug it in. Let's see if our voltage comes up. I hope it does. Plug it in the amplifier now. We're going to see if it comes up. Oh, wow. Yes, it did. It's a little bit high, but that's good. That's really good. So that's some high voltage there. We're almost at 3,000 volts. Let's see if it bleeds down when I turn it off. We have filaments. Okay, that's good. Before it was really, really bad. So let's flip it down here and see if it bleeds down. That's good. Kind of high, but that means it ought to get down. And it's bleeding down properly. That really makes me happy, because if you've been watching this video, you know that we've been having low voltage. We've tried everything under the sun to see if we can get the voltage up. So that's good. Now, the only thing I'll need to do now is actually hook it in line, put it on my big dummy load, and see if it makes power. But I do that off camera for purposes only. Because of the fact that we had such low voltage, that I am absolutely positively sure that this thing's going to be working back to its 100%. We had some dead caps there, and maybe even possibly a few diodes that didn't survive any of that, even though they checked out good. It's best just to put new ones in. Absolutely wonderful. Bit high, but we'll see. I think it'll be working. It's going to get down is what it's going to do, guys. Thank you guys so much for watching the We'll Fix It team. Rocking and rolling. Not a technician, but doing the best I can. All right, we out.